Okay, by this time you should have this filled out. If you're looking at this video, then you've gotten to about number 5 in your PhET lab. Now in this lab, we're going to be looking at a different value of K. We've done Kc, which is products over reactants of molarity. We've done Kp, which is products over reactants with pressure. And now we're going to do what Ksp, which is actually just another equilibrium constant of, and I'm going to write this over here, a solute going to its ions. Basically, it is a solid solute dissolving in water. And Ksp is going to be the same as always, right? It's going to be products. So let's look at sodium chloride. That's going to be our first one, and then I'll go back to the sim. Sodium chloride is just going to be products over reactants, but in this case, notice that in every case, when we are dissolving a solute into water, the solute is a solid. So that never appears in the equilibrium constant. So which basically Ksp is going to be the products. Okay, so let's look at how this simulation works. Let me just explain a few things before we start using it more. I'm going to reset this so we can start over. Okay, so when I start adding a salt, this is the table salt, so I'm over in this section, and I start adding. Notice that the salt starts as a lattice, but then the water breaks it apart, and it becomes, these are now individual sodium and chloride ions in solution. Now at this point, I'm unsaturated. I don't have anything solid at the bottom of my beaker. Everything is being dissolved. Now when you look over here, what you're going to be looking for, a couple things. One, this tells you how many actual, counts the number of ions or particles that are dissolved. And then your volume in liters, you can find that here. You can actually see that here on the graduations here, but this is the easiest place to get it. So I'm unsaturated, and it told us before we got to number 5 to keep adding it until no more dissolves. So I'm just going to keep doing that. I'm going to watch it go into solution. There it goes. I'm at 144. Notice that this value keeps changing. 144. Now I'm up to 181. Okay. So I am, look at that. I am still unsaturated. But if I add one little bit more, let's see what happens. None of that is going to dissolve. Now notice there still is what we would call, remember, a dynamic equilibrium. Some of the chloride and sodium ions are coming back on, but others are going off. And notice that this is not changing. I am at equilibrium. But again, the equilibrium is dynamic. I don't really care about these bound ions or these total ions. What I'm really going to focus on in this PhET are the dissolved ions and the number of liters in my vessel. Okay, so let's go back to the handout. So this is my KSP, and what we're going to do is what we have done before. We're going to calculate the equilibrium concentrations of our ions. But we're also going to do one more thing. We're going to learn about what is called the molar solubility. All right, so let's start with what we know. It says using the information here, so remember we said that KSP was equal to sodium plus times Cl minus. All right, it says calculate the KSP, and we're going to use the sim to do that. All right, now, if I want to calculate this, right, then I need the equilibrium concentrations of my ions each. So if I look at my simulation has the ions, the number of ions dissolved. Again, we're not worried about that, just how many ions are dissolved. And I would say it's about 181 for each one. Of course, they're going to be equal because for every one sodium chloride, I get one of each. So what I'm going to do is I'm going to use that. These are my equilibrium concentrations, ions per liter. Now, I don't want ions per liter. What do we want? We want concentration, which is moles per liter. But I can convert ions to moles, and then I have moles per liter. So let's do that. So for sodium, I have 181 ions, and we know that 6.02 times 10 to the 23rd ions is 1 mole. Divide all of that by 5.0 times 10 to the minus 23rd liters, and I get 6 moles per liter, or molarity. Okay. Now, we also have, for chloride, 181 ions, so the concentration is also 6 molar. So I'm going to circle these. Those are my equilibrium concentrations given to me by the sim. I'm going to plug those in. KSP is equal to 6.0 times 6.0, which is equal to 36. Now, in order to do this calculation, remember, when you do these on your own, you have to make sure you're at equilibrium. You have to make sure you have solid at the bottom, and that these numbers are no longer changing, or you're not at equilibrium and you can't use those numbers in order to do your calculations. Okay, now we know about that. This is my KSP. And now what we're going to do is calculate something new. It's called the molar solubility. Remember when I used to tell you, when we would calculate X, I would say we're not done yet, right? We're not done yet. We have to take X, plug it into those equilibrium concentrations, or the equilibrium values, plug X in to get the concentrations. Molar solubility is actually, I am done. Molar solubility is just X. That's all it is. It is defined as the number of moles of solute. Number of moles of solute. That is your solid that can dissolve. And I should say number of moles per liter of solute that can dissolve before saturation. Okay, so how are we going to do this? All right, we are going to do this with our standard rice table. All right, so I'm going to put NaCl is going to Na plus Cl minus. Now, in this case, when I first start, I dump my salt in, hit the pause button. Nothing happens. So my initial concentrations of these are 0. We don't care about this one because it's not in the equilibrium expression. Ignore it. Now, every single time I dissolve a salt, I'm always going to go in this direction. So that means this is plus and this is plus. My change is X. That's going to be our molar solubility, so I'm going to start calling it that. My molar solubility is X. I have no coefficients here, so I am done. So this is R, this is I, C, and now let's draw our line, and we have E. So this is going to be X, and this is going to be X. We know that all we have to do is set these equal, take our product, our 2 ions here, X times X is equal to 36, or X squared is equal to 36, so X is equal to 6. Now, in this case, the molar solubility and the equilibrium concentrations are the same, but that is not always the case. So what I'm going to do next is we're going to go down to, I want you to stop this video, and then you're going to work through the rest of the handout, and then we're going to work problem part 2, mercury bromide.